Okay, this is 14.13 sample problem. This function's a little more complex, but it's just like the previous one. We're looking for the cross sections at x equals 0, y equals 0, and y equals x, and the level curves. So let's take a look. First, when x is equal to 0. Okay, when x is equal to 0, it basically cuts the function in half so that it now becomes f is equal to e to the minus y squared sine of y squared. And what is that going to look like? Well, it'll be symmetric because it's sine of y squared, so it'll head in each direction the same, just like a sine function, but a little bit taller and exclusively above the axis. And of course, this is a dying exponential, so that means it's going to be a sine function that sort of moves to either side, but does so without dropping to 0, and it's going to basically turn into 0 not too far away because the exponential is going to guarantee it. So at least in the y versus z profile, it kind of looks like that. It sort of has two hills on either side of the origin that it slowly moves up to and back down again. But then it doesn't get a second amplitude because this guy dies off really, really quickly. Okay, in the y direction, it's going to look exactly the same. So when y equals 0, we're on the x-axis, and it'll just be the reverse. It'll be e to the minus x squared sine of x squared. So once again, other than the axis switching, it looks exactly the same. So this guy's fully symmetric, so it'll kind of look like this and this. And so from every direction, it looks like that, even y equals x, because all that happens here is this now becomes f of, if I sub out the x, it'll be e to the minus 2x squared and sine of 2x squared. So although it'll happen along the diagonal, it'll be the same thing as these. It's just in terms of x and y, it'll happen out at radical 2 on the x-axis is where that projection will be. So it's roughly the same shape. If I look at the 2x axis, then it's going to basically look like the same thing. And then, of course, if we slice through this, we're going to get these concentric circles. That's what the contour is going to look like going up the z-axis. So it'll basically be a series of concentric circles that show the contour plot. And they'll get closer together and further apart as we're carving into these pieces versus these pieces. And then further out, the circles will be really, really far apart. So concentric circles is the shape of the level curves.